Okay, let's continue to our chapters. Okay, particularly we're gonna talk about the system of linear equations using inverse matrix method. Let's get started. Right, inverse matrix, which is denoted by A inverse, okay, can be used to find the solution of system of linear equations. Right, and this is two conditions that the system of the SLE can be solved using the inverse method. Okay, first the matrix the matrix coefficient of the SLE should be square matrix, right? Should be square. The second one, the coefficient matrix should be non-singular matrix. And what is non-singular matrix? Which is determinant of matrix A is not equals to 0, right? Right. Now, we have this system of linear equations. Okay, this system. Okay, so let's say we have the system of equations of a n times n systems, right? So it means consists of n number of equations and number of unknown variables. Okay, and this system can be written as the matrix form like this, right? A times x equals to b, right? Now from here, since A or the coefficient matrix is has determinant which is not equals to 0, it means matrix A is the invertible matrix. It means matrix A has inverse, right? And now from here, we will derive the formula of the solution or unknown variables by using the inverse matrix. Right, so now we have uh, this form, right? A x equals to b, right? Right, so if we multiply a x equals to b, okay, with a inverse from the left side, so from the left side, so we have a inverse, right, times ax equals to a inverse times b. Okay, so both sides are multiplied by the inverse from the left side. Remember, the multiplication of the matrices uh, uh, doesn't satisfy the commutative formula, right? Which is a times b is not equals to b times a. So it means if I said these both sides are multiplied by A inverse from the left side, then the A inverse lies on the left side of these two matrices, right? So that's that we have, right? Now, because we know A inverse, so this is what happening, right? So A inverse times A equals to what? Identity matrix, right? And identity matrix times any matrix should be equals to the matrix itself, right? Then now for the left hand side we just have x only, right? And then for the right hand side, yes, we just have a inverse times b. So this is remains, right? Then I can say here the formula of the solution of the system by using inverse method is this: A times A inverse times B, right? Let's have a look at the example. Alright, so here are the examples. So let's say we have a system of equation consists of two number of equations and two unknown variables. Okay, and from here we can form it as the matrix forms like this. So here we have matrix 2, 1, negative 4, 3, and this is unknown variables, and this is the right hand side, right? And from here we have to check whether this matrix, which is a coefficient matrix, okay, is invertible or not by checking the determinant. Okay, and we can see here determinant of this is 10, which is not equals to 0, and it means this coefficient matrix is the invertible, right? has the inverse, right? And now what is the inverse of this? And we can using the formula which has been explained in the previous slides. If we have 2 times 2 matrix, so the A inverse, remember this, equals to 1 divided by determinant A, okay, times, and this is our matrix. Let's say if we have matrix A equals to A, B, C, D, right? And here we have matrix D, elements D, and then we have negative B, and then this is negative C, and this is element A, right? So this is the formula of 2 times 2 matrix to find the A inverse, right? Then we have the inverse of matrix is this, right? From here, we can put it in the formula that's the unknown variables equals to A inverse times B. And this is the result after we compute, right? Okay, it's quite easy. Right, and this is another example. Okay, let's say now we have a system of linear equation consists of 3 times 3 like this, right? And after we form it as the matrix in matrix form, then this is the systems in the matrix form. So this is matrix A, this is unknown variables, and this is a vector B, right? And now by using the methods to find the A inverse, do you remember we can use adjoint matrix, right, to find the inverse, right? We have a formula of A inverse by using adjoint matrix, right? And this is the result of A inverse, right? And you can check if this A inverse is correct, okay, by computing A times A inverse should be equals to matrix I or identity matrix, right? So you multiply this and this one should be I, right? Okay, this is our A inverse, right? Then now the solution of this is A inverse times B, which is 5, negative 3, and 7. Okay, where x1 equals to 5, x2 equals to negative 3, and x3 equals to negative 7, right? Right, and this is another example. Okay, let's say we have 2 times 2 system of frequencies like this. Okay, as similar to previous examples, and this is our matrix A, and this is unknown variables, and this is our vector B. Right, and now we have to check whether this matrix is invertible or not. Right, so if this is matrix A, then here we have determinant of matrix A equals to 1 is divided by negative 3 subtract with negative 2 times 1 is negative 2, right? Which is equals to 1 is divided by negative 1 or equals to negative 1, right? And now, since this is not equals to 0, it means matrix A is invertible. And now the A inverse, okay, equals to 1 is divided by negative 1, okay, 1 is divided by determinant A, times negative 3, 2, negative 1, 1, right? Which is equals to 3, negative 2, 1, negative 1, right? So this is our inverse. Then to find the solution or x1, x2, just multiply the A inverse 3, negative 2, 1, negative 1 times with B 4, 2, right? Equals to 12, negative 1 is 8, right? And here 4, negative 2 is 2, right? Yeah, and this is the solution of the system. Okay, how about B, part B? Okay, so it's not really complicated, okay? We just look at this one is AX, right? A times X, okay? But we have something else here. So what we can do? So you just need to move this vector to here. right? Just put it together in here. Then we have, this is remains the same. So we have 5, 3, 1, 1 times x1, x2, right, equals to 18, 22, subtract with 25, 40. Okay, because the sign of this positive, then when we move it becomes negative, right? So the right hand side that we have now is, this is negative 7 and this is 8, right? So now the system of linear equations becomes 5, 3, 1, 1 times x1, x2 equals to negative 7, 8. And then the next one, you just need to find what is the A inverse. But first, you have to check whether this matrix is non-singular or singular matrix. Right? Right, I think it's enough for this method, and it's quite easy. Right? You can just practice in some other exercises. Right? Thank you very much. Bye bye.